Alright, the current problem is a place kicker must kick a football from a point 36 meters, about 40 yards, from the goal. Half the crowd hopes the ball will clear the crossbar, which is 3.05 meters high. When kicked, the ball leaves the ground with a speed of 20 meters per second at an angle of 53 degrees to the horizontal. A. By how much does the ball clear or fall short of clearing the crossbar? B. Does the ball approach the crossbar while still rising or while falling? Alright, what exactly does the question ask you to find? Pause the video for a minute and write down your answer. Part A asks for the height of the particle when it has traveled 36 meters. What does Part B ask for? Pause the video and answer the question. If you ask, does the ball approach the crossbar while still rising or falling, that is correct. However, I rephrased it a little differently. Is the particle's maximum height before or after the 36 meter point? Why does rephrasing it this way help? Pause the tape or pause the video and answer the question. Draw a picture or diagram of the situation and label your unknowns and your knowns. Pause the video and do the diagram. Okay, if I were to draw a diagram of it, first of all, you're about 36 meters. Alright, and you have the crossbar here, and that's at 3.05 meters. And you have the particle whose initial velocity is 20 meters per second, and the angle here, theta, is equal to 53 degrees. From the diagram, do I know the particle's horizontal and vertical components? Pause the tape or pause the video and calculate those components. Yes, I do. I know that the Iy will be equal to the magnitude of V, which we know, and it'll be times the sine of theta, which we also know theta, and that's going to be 20 meters per second times sine of 53 degrees, which that'll be equal to 16 meters per second. Vix is equal to the magnitude of V cosine of the theta, which will be equal to 20 meters per second times cosine of 53, and that's equal to 12 meters per second. There are two ways to calculate the time the particle takes to reach the position x equals 36 meters, y equals 3.05 meters. Identify those two methods. Pause the video and write down your answer. The first method would be to use the vertical component and calculate how much time is required to reach the vertical height of 3.05 meters. The second method is to use the horizontal component and calculate how long it takes the particle to travel 3.36 meters at constant velocity. Which method do you think will get you to the answer quicker? Pause the video and decide which one you're going to use. I start by calculating using the particle under constant velocity model and calculate the time required for the particle travel horizontally 36 meters. So go ahead and calculate this. Pause the video and do the calculation. So we know that the distance to the goal, xg, will be equal to xi, whatever the initial position is, in the x direction, plus vix t. Note that, of course, xi is equal to 0, and we know what vix is, and we know what xg is. So we can solve for the fact that 36 meters will be equal to 12 meters per second times t. And so t will be equal to 3.0 seconds. Now that I have the time, how can the height of the ball or the particle be determined at that time? Pause the video and figure out how that's going to be done. For the next part, we can use the initial velocity in the y direction and set up the equation that y equal yi plus vyit minus 1/2 gt squared. And we already know t, so we can look at y at that time t. We know that y will be equal to 0 plus, well, we know that vyi is 16 meters per second, and the time is 3 seconds, minus 1/2 g, which is 9.8, t, which is 3, and that's squared. That comes out to give that y will be equal to 3.9 meters, which clears the goal. So we now have that part A is solved. Now let's ask a question. If I could figure out the time at which the particle reaches maximum height, what would that tell me about whether the particle is falling or rising when it reaches the goal? Pause the video and consider it and write your answer down. How would I find the time required to reach the maximum height? Pause the video and figure out how you'd find that time. Is there a relation between the vertical components of velocity and the time to reach maximum? Once again, pause the video. If you have not figured it out already, think about it and see if you can figure it out. Okay, well, I know that in the vertical direction, Vy final will be equal to Vy initial minus Gt. And we know that when it reaches the maximum, it reaches the very top, Vyf is 0. So we have 0 equal to Vyi minus Gt. Now, since V, we know what Vy, we know what I is, we know what G is. So that simply says that 16 meters per second over 9.8 will be equal to T. And that is going to be equal to 1.63 seconds. Now, what is the significance of that time being less than the time to reach the goalpost? Think about it for a minute. Pause the video. That tells you that the particle is on the way down. So since, so particle on way down. And that now says part B solved. End of problem.